continue with question 4. I'm just going to start by reading the question. I think on that. Oh, come on. I think I just present. So I just need to go back to that slide. Just give me a second. So with question 4, what is happening here is you have the same wording as question 3 with the only exception that the condition is now basic. So you do need to do one extra thing when you have a basic condition. Obviously, when you use cohes, you're assuming acidic condition because you use H plus ions to balance the half equations. So if the condition is basic, then you do need to do another thing. And what I tend to do is I still use cohes and then I convert the product to basic. So I'm just going to go through part A again. This is identical to question 3A, but I'm just going to do it again from scratch, just in case you haven't done 3A or I don't know. All right, so we need to have the oxidation numbers. So this is 0, this is -2, +5, this is +2, and -2, +2. So once again, copper has an increase in oxidation number, which means that it is the reducing agent, and the nitrogen in nitrate ion has a decrease in oxidation number, so it is the oxidizing agent. Oxidizing agent. All right. This, I don't think there's anything I could split. This is already an ion, and that is an covalent substance. I think that's supposed to be gas. I don't know why I have it as AQ. That should be a gas. That's strange. All right, I don't think I've ever seen nitrogen oxide aqueous. Okay, so now we're going to do oxidation first. You can definitely do reduction first. There's no preference here. I have copper going to copper 2+. And there is no oxygen and hydrogen to be balanced, so you just add 2 electrons. So this equation, if you look at it, it doesn't indicate the condition. It could either be acidic or basic or any other condition. So there's nothing else you have to do to it because you definitely don't require any hydrogen ions or hydroxide ions for it to happen. I think all the excitement is going to happen in the reduction half equation. So we're going to start with NO3 minus and move on. Well, it is reduced into NO gas. All right, I need to add 2H2O. I'm just going to balance it as you would using cohes. So key elements already balanced, and I need to add 2 water. This side I need 4H plus, and I'm going to need to add 3 electrons to balance the charge, which agrees with the decrease in oxidation number from +5 to +2. So clearly this is acidic condition. You can see the H plus ion here. And before you finish, you need to convert this half equation to a basic condition. And I guess the long way, sometimes there are shortcuts, but it really takes observations. The long way is you basically need to neutralize the H plus ions. And neutralization will occur if you have hydroxide ion. So because I have 4 H plus ion, I am going to add 4 hydroxide ions to it. And I'm going to add the same amount of hydroxide ion to the other side so that my equation is still balanced. Now if you combine H plus and OH minus, you should end up with 4H2O here. And I'm just going to write the rest of the equation again. So I have NO3 minus plus 4H2O plus 3 electrons going to NO plus 2H2O plus 4OH minus. You definitely want to simplify the water. So final answer is NO3 minus plus 2H2O and 3 electrons going to NO and 4OH minus. So we're just going to do a quick check to see whether our equation is still balanced. I'm going to do a charge check again. There's a 4 minus on the reactant side and 4 minus on the product side, so that looks good. You have time to check every single element. We still need to do an overall. I definitely would convert any half equation to the basic condition, and obviously when you add them together, the overall is going to reflect a basic condition. the number of electrons shouldn't change regardless of what condition it is under, because the number of electrons being transferred depends on the change in oxidation number, not the other ions that are present. So I still need to triple the first half equation and double the second one in order to get 6 electrons. And I'm just going to write the answer here. So you have 3 copper, 2 NO3 minus, and 4 H2O, going to 3 Cu2 plus 2 NO and 8 OH minus. Okay, let's be disciplined and do one last charge check. There's 2 minus on the left. That's 3 plus, this is weird. What did I do? Okay, 3 plus, 6 plus, sorry. That's why it's weird. 6 plus and 8 minus, so that's 2 minus, so that's good. But then I'm paranoid now, so I'm going to check the oxygen as well. There's 6 and 4, so that's 10. 2 and 8, so that's 10. That's question 4a.